Hello once again, everyone. Welcome to our mathematics class today. I am Victor Odigoma Ohia. In our class today, we are going to be, of course, I'm introducing a new topic today. We are going to be looking at the relationship between standard form and logarithm of numbers. Okay, logarithm in base 10. All right. So we are going to be looking at standard form. There is a relationship existing between standard form and logarithm of numbers. Please, this class is not going to be it's not going to be a class you will joke with seriously, because I'm going to show you some secrets in this, and you are going to be able to learn a lot. Thank you so much for being there. All right, let's go. Now, we are coming from the perspective of standard form. In junior secondary, one must have come to know what it means to put a number in standard form. Do we get that? One must have come to know what it means to put a number in standard form. All right. So you ordinarily know that if I say, of course, standard form is an expression of a number in the form of, say, a times 10 raised to power n. So here, where a lies, this a lies between 1, a lies between 1 and 10, and this n is an integer. Okay, integer meaning it can be positive or negative. All right. So if I take, for instance, now let's look at this. If I give you let me start from here, 4,000. Put 4,000 in standard form. That's something I need to. You know that this is 4,000, and it's obvious that the decimal point is here. Hmm? This is 4,000. There is something I need to make use to show you with that. That's why I'm trying to point that out to you. So it's clear that this is 4,000, and it's clear that the decimal point is here. After this, okay, even though we didn't put it. All right. Now, we are going to write this 4,000 can be written as 4 times 1,000. True of us. Yeah, this can be written as this. And I can write this thing. You recall indices, index. All right. So I can write this thing as 4 times 10 raised to power 3. Do you see that? Can you see that this can be likened to this? That this can be likened to this? Yeah. So this expression now is in standard form. This thing now, I've written 4,000 in standard form. Okay, there's something I want you to discover. The number of digits that are here, there are 4 in number. And the power of 10 here is 3. Okay, so am I going to be too fast to tell you that if you want to write a number like this, greater than 1 in standard form, that it is the number of digits before the decimal point minus 1 will give you the power of 10. Let me repeat it again. The number of digits before the decimal point, okay, minus 1 will give you what? The power of 10. So the number of digits here are 1, 2, 3, 4, minus 1, making it 3. That will give you the power of what? 10. Okay. Now, alternatively, some others can also say that if you have that number that is greater than 1, like this 4,000, decimal point is here. I have said it already, that you move the decimal point before the first digit. Now you check how many times you were able to move the decimal point, and then that will be the power of 10. So if the decimal point is here and I moved it 1, 2, 3, to stand before the first digit. You can see that I moved the decimal point 3 times. So I can write this now as 4 times 10 raised to power 3. Okay. So this is an alternative way of presenting a number in a standard form. Do we get that? So that is 2 ways we can be able to do this. So I'm sure that explanation is very, very well taken. Now, let me also look at another instance here. The next instance is, take for instance, we now have, this is, let's say, example A, and this is example B. Let's assume we have something like 5100. 5100. So you already know what this is going to be. So this is 1, 2, 3, okay, 4 digits. So you are now going to have 5.1 times 10 raised to power 3. Okay, you ask me why is this one appearing here, and I will tell you because it is non-zero digits. Okay, you can see the other ones are negligible, so I didn't put them. Okay, so this can be written like this. Let's advance a little bit. So remember, we're heading somewhere. Where we're heading to is to see the connection between the power of this 10 and what is going to be used to do, what we're going to use it for when we now venture into logarithm of numbers. So take for instance, we have something like, let's say C, we have something like 457676. This is still 4-digit, a 4-digit number. So you can move the decimal point as we have been doing. So you will have 4.576 times 10 raised to power what? 3. All right, I have explained to us why this is so. Number of movements 1, 2, 3 before the first digit. So I am pretty sure that that explanation is well taken. Okay, now can I take one or more examples on that? Take for instance, we will have, I've given, this is C. Let me say, take for instance, we have something like this. If we have something like 32.4, did you realize that this will be, how many digits do we have here before the decimal point? You see, we have 2 digits before the decimal point, and this is going to become, if you move this directly in front of the first digit, you are going to have 3.24 times 10 raised to power 1. Do we get that? Okay, let me show you a secret here, something sort of. Okay, now, do you realize that if I write this number, I'm sure you know what it means to write a number in changing a decimal to a fraction. So you realize that if I want to change this value, if I want to change this to fraction, what is going to be is 324 over 10. I've converted this decimal value to fraction. So look at this and look at this. This is 10, like 10 raised to power 1. So I can change this thing now to standard form, and it will be 3.24 times 10 raised to power 2 all over 10 raised to power 1. Do you follow that? All right, did you realize here that this is 10 raised to power 1, this is 10 raised to power, and you recall that in indices, if we have excuse me, if you have 3.24 times 10 raised to power 2, then here 10 raised to power 1, do you realize that you can subtract the powers here? Okay, And when you are subtracting the power, this is like 10 raised to power 2 minus the, all right, divided by 10 raised to power 1, which is now going to be 10 raised to power 2 minus 1, which is 10 raised to power 1. So this thing now is like 3.24 times 10 raised to power 1. Both of them are they the same thing. So this is another way of breaking this down to the best of our explanation. I'm sure that is taken. Let me also take one more example on this. Okay, we also have something like this is E. Okay, if we have a something like let me say 8.04, how can we be able to write this? How can we be able to write this in standard form? You realize that the decimal point is already existing in front of the first digit, so there is no where to move it to, and this expression is already existing in the format of a times 10 raised to power n. So this is now like a 8.04 times 10 raised to power 0, because the value, this decimal point was not moved. You get it now? So this is a way of expressing this value in standard form. All right, now what about when we now have figures that are less than 1? Okay, I have taken enough of those that are greater than 1. Now let me consider a situation whereby we have numbers that are less than 1. Look at these values here. If you observe, you realize that these numbers are less than 1. So I want us to look at how we can write these, present these numbers. The previous ones we have been looking at, all of them are greater than 1. Okay, and we have been able to see that the power of 10 there is realized from the number of digits before the decimal point minus 1. That is what gives us the power of 10. So let's also look at a situation like this where the numbers are less than 1. Remember, we're heading somewhere. We're trying to connect this to logarithm of numbers. All right, follow me. How can I write this in standard form? Let me show you something. You see that this 0.47 can be written as 47 over 100. Okay, so do you realize that this now is easy to write this in standard form as 4.7 times 10 raised to power 1. I've explained that it is number of digits, or you move the decimal point to the first digit. Okay, so if you do that, it's only once it's going to be moved here. Or you say number of digits minus 1, that would be the power of 10. So this is all over 10 raised to power 2. All right, now do you remember what we are saying in these indices? That if you have 10 raised to power 1 divided by 10 raised to power 2, you realize that this will be 10 raised to power 1 minus 2, which will give you 10 raised to power minus 1. So it then means that this is 4.7 times 10 raised to power minus 1. Okay, all right. Do you also realize that, oh, this will now be written in standard form as 4.7 times 10 raised to power minus 1. All right, what about this? That's 0.8. And 0.8 is the same thing as 8 over 10. And this one in standard form is the same thing as 8 times 10 raised to power 0. Okay, I'm sure you know this raised to power 0 is 1. 8 times 1 is still 8. And this is 10 raised to power 1. So Will you get this now if I write it as 8 times 10 raised to power 0 minus 1 because of the division of this, and the knowledge of indices helping us out. So you see that 0 minus 1 will give you minus 1. So this is 8 times 10 raised to power minus 1. So will you take this now to become 8 times 10 raised to power minus 1? Okay. Now, if let me just check out something here. It's like all this one. Let me jump this, and come down here so that I can connect what I'm trying to explain there. So look at this. If you have 0.0084, okay, this last one, I can rewrite it as 84 over 1, 1, 2, 3, 4, 1, 2, 3, 4. And this in standard form will be 8.4 times 10 raised to power 1 all over 10 raised to power how many? 4. 4. So you know what will happen here now? That this is like 8.4 times 10 raised to power times 10 to power 1 minus 4, which will give us minus 3. So this in standard form is 8.4 times 10 raised to power minus 3. Let's see whether we can balance something here. Do you realize that the number of zeros here is 1 and the power of 10 is 1 but negative? Do you realize the number of zeros here is 1 and the power of 10 is 1 but negative? Do you realize that the number of zeros here is 1, 2, 3 and the power of 10 is 3 but negative? Now, will you follow me if I say now that this will be in standard form 7.4 times 10 raised to power minus 2 because of 1, 2. And this will be 1.02. Remember, this is there. So we have to write it. Okay, it's non-zero. So times 10 raised to power minus 1. Would you follow me on that? I can still explain this to you. That what is my conclusion? Where am I heading to? Where I'm heading to is that when you have something like A, B, C, D, E, F, when you have something like 0.0000, let's say 61, that this thing is the same thing as 6.1 times 10 raised to power 1, 2, 3, 4, 5 minus 5. That's the simple explanation as fast as possible. I'm sure you will take that. All right. So if I care to give you further explanation on that, I can still show you that, where is that one now? That 0.074 is the same thing as 74 over 1000. 1, 2, 3. 1, 2, 3. Which is, this will be 7.4 times 10 raised to power 1. And this will be 10 raised to power 3. And you know that 7.4 times 10 raised to power 1 minus 3. That will give you 7.4 times 10 raised to power minus 2. So can you see it there? So this is my way of bringing us close to the knowledge of standard form. And then can we quickly connect this to logarithm of numbers? Okay. Now, when we say the logarithm of numbers, the logarithm of a number to a given base is the power to which the base must be raised to get that number. And if we come to logarithm of numbers like this, it has two component parts. The characteristics part and the matrices part. So if I have, say number, okay, you will see standard form standard form and then the log of it, you will see with me the connection between these things we are going to do here. So here we have, oh, all of these ones are less than 1. But let me bring them and then also bring those that are greater than 1, which you have looked at previously. You can still check them back. Okay, look at this. If you have 0.47 and 0.074 in this day, and maybe pick another one. Okay, let me just take these two. And let's assume you now have a number that is greater than 1. A number that is greater than 1, like 724, and let's say 32.5. Okay, now do you realize that the standard form of this will be 4.7 times 10 raised to power minus 1, and this will be 7.4 times 10 raised to power minus 2, and this will be 7.24 times 10, according to the explanations I have given, raised to power 2 to be positive, and this will be 3.25 times 10 raised to power 1, because there are 2 digits before the decimal point here. All right, how does this now connect to the logarithm of this, which I told you has 2 components parts, the characteristics part and the mantissa part? So you realize that the power of 10, when this number is expressed in standard form, is the characteristics part of the logarithm of the number, this number. That's to say, this minus 1 is the characteristics part of the logarithm of this number. Do we get that? So here, but we express it in bar notation. So this, for those that are less than, the power of 10 is less than 1. We call it like this thing now will be written as bar 1 point. And then this will be written as bar 2 point. And this will be written as 2 points. And this will be written as 1 point. So assuming I'm looking for the logarithm of 0.47, the characteristics part will be bar 1. And the mantissa part will be 47 under 0. I will now check in my logarithm table. This is logarithm of numbers. This is logarithm of numbers. I will check 47 under 0. So this is, I'm sure you can see this. This is 47 and this is under 0. So 47 under 0 is 6721. 6721. So this will be 6721. So you write 6721. So this is the logarithm of this. Do we get that? So, and then let me go down to, okay, let's take this. This will be 74 under 0 as well. You check in your logarithm table, 74 under 0 is 8692. 8692. Okay, what about 724? That is 72 under 4. You also check 72 under 4. This is 72, and you follow under 4 and come down 72 under 4. Okay, 72 under 4 is 58597. 8597. 8597. And then what again do we have? 32 under 5. So this have been taken care of by the characteristics you are seeing here. So we check 32 under 5. 32 under 5. 32 under 5. 32 under 5. 5119. 5119. So this is how to, connect standard form to logarithm of numbers. As you can see, we have been able to connect the power of 10 when the number is expressed in standard form to the characteristics part of the characteristics part of the logarithm of that number. The characteristics part is the power of 10 when the number is written in standard form. So I am sure that this explanation is good enough to connect us. We are here now. This is where we are. And by this explanation, one have been able to know how to connect to this place. From here, we are going to be heading down to now simplifying problems in logarithm of numbers. Okay, and we are going to come across powers, roots, multiplications, and divisions. Now I am going to also bring us to that, especially as it has to do with these ones that are you know less than one. Especially like if I gave you to simplify without calculator 0.47 times 0.074. Okay, this and possibly raise this to power 2. So how will one be able to, you have found this logarithm of this, and you have found the logarithm of this. By this multiplication, you are going to add their logarithms. And in adding their logarithms, you are going to encounter bar 1.6, okay, and so on, and then plus bar 2.8, and so on. You see, the addition of this is what we call, addition of bar notations. I'm going to handle this as a separate discussion. I will discuss the addition of bar notations, subtraction of bar notations, multiplication of bar notations, and division in bar notations for this, because this now we warrant that you are going to multiply when you have done this addition. Assuming I ended this addition and here I have, let's say, bar 3. Take for instance bar 3 point whatever, and I'm going to multiply this bar 3 by 2. One need to know the issues because this is the most critical point. So I will advise us to follow me in the next class as I discuss bar notations as a separate discussion. Thank you for being there.